Okay, good afternoon, everyone. Welcome to Primary and welcome to the School of Engineering and Material Science. We call it SAMS for short. My name is Hisham Ajali. I'm a senior lecturer in thermofluids, and today I'm going to talk to you about mechanical engineering. Check-in, so we have, a good number of attendees. So welcome everyone again. And we keep getting more prospective students logging in. So welcome to those who have just joined. So I'm going to go through a few slides just for you to understand how we teach mechanical engineering in our school. Okay, so just to give you an idea how the university, Queen Mary University, is structured. So we have three faculties. Here in the middle, you can see our Faculty of Science and Engineering, which is itself made up of 5 schools. We are the School of Engineering and Material Science here, and the school offers many programs, including mechanical engineering, and this is what we are talking about today. Okay, so why mechanical engineering? I guess that you are here today is because you are interested in the, oops, this didn't have done that quick. Yeah, I was saying you are here with us now, so probably you are very interested in mechanical engineering. Obviously, engineers are always in demand. We cannot stop demand of engineers because we are surrounded with technology, so this cannot stop. So, and certainly mechanical engineering is the heart of it. Here in Queen Mary, if you're interested in that aspect, £30,000 per year is the average salary of a SAMS graduate. This data comes from HESA, which is Higher Education Statistics Agency. That was back in 2021. So I guess now it is a bit higher. So it is not a bad starting salary. Obviously, being mechanical engineer, it's very employable because you touch up on a wide range of careers, and it's broad in terms of background, which makes it suitable for many industries, including teaching. Because my own background is mechanical engineering, and now I'm teaching mechanical engineering. Okay, so here at our school at SEMS, just to give you an idea, again, why choose us for mechanical engineering. We are part of Nursing Group. You may have heard about this group of 24 UK universities, top universities, and we are the most ethnically diverse university within the group. So that's not too bad at all. And we have excellent links to industry. Obviously, engineering means that we need to work a lot with industry, and we have very strong links with that. We have excellent research reputation. I will talk about this in a moment. Why am I mentioning this here is because obviously research and teaching are intimately linked. Teaching is informed by research, and so that we know what's going on, etc. I can adapt, what is needed by industry. And obviously all our programs are accredited by the relevant body, and in this case for mechanical engineering is the IMechE, or Institution of Mechanical Engineers. They basically say that our programs are fit for purpose, and they check up on us every 2 years, so help to keep ourselves up to date. Okay, so mechanical engineering here in our school, just to give you an idea, we have more than 1,500 undergraduate students. So that's including first, second, third year, and fourth year for those who do an MEng. As I said earlier, the most diverse university, 70 countries represented. Many, I mean, you can make friends from all over the world, but still from the comfort of your own city if you live in London. And in terms of ratio male-female, if you look at the national average, only 16.5% of engineers are female. That's according to Engineering UK. But however, in Queen Mary, we did that, and we are at 26% in our school. When I say our school, that includes all programs. This is not only mechanical engineering. We have 209 members of staff, so it's quite a big school, and a bit less than half of that are academics teaching. Okay, so talking about academics, they achieved in terms of research a very, very respectful ranking in the last REF, which is a research excellence framework. That was like a couple of years ago. We came 7th in the UK for engineering research, and believe me, that's great when you have Oxford and Cambridge out there. We have a strong student focus. We'll talk about this in a moment. We want to be excellent in teaching, and for that, we make sure that all our teaching staff have some sort of qualification in terms of teaching or recognition. So we have 2 national teaching fellows. That's really the top of the top. In the UK, we have 3 principal fellows of the Higher Education Academy, senior fellows, etc. Most others are fellows of the Higher Education Academy. This shows that it's not only good to be good at research, but we have to be able to convey the knowledge to the students. And because we are part of Faculty of Science and Engineering, so we are highly interdisciplinary, so we work with our friends in the other schools. In terms of teaching, our school back in 2000 it introduced what we call PBL learning, problem-based learning, PB learning. That was like half a century ago almost. And since then, all our engineering programs are taught using PBL, this PBL approach. So what is it? You learn through hands-on approach. So there are hard skills that you will develop, like workshop skills. You have to measure things, you have to try to figure out things, physical things, but also you will learn soft skills like team working, report writing, presentation, etc. So what you will be studying in year 1. So these are the modules for our first year mechanical engineering program. So you'll be doing obviously maths. That's very important in engineering, associated with computer with bit of programming. So, and that includes Python and MATLAB. You can see there 1 and 2, which means that there are 2 modules, one in semester 1 and another one in semester 2. You also do some hands-on work as part of 2 modules called with experimental design and practice 1 and 2, again, semester 1 and semester 2. You'll be looking at materials that are used in engineering. You'll be looking at fluids and thermodynamics, engineering design, and exploring mechanical engineering. That's a module that is specific. This is the one I'm talking about now. Exploring engineering is a module where all our engineering students, they all take it, because it will give them a taste of different parts of engineering. So if you start mechanical engineering, represented by a car, as we typically do, you can see some aerospace engineering there. You can see bioengineering. You can see robotics. What else? You can see sustainable engineering with the wind turbine. So you'll be touching upon almost everything. It will give you like a holistic idea about engineering that we offer in our school. It's also important because after your first year, we are flexible enough for you to switch programs. So, for example, you may start doing mechanical and then say, oh, after all, I want to do aerospace. You can do that, and vice versa, or any other subject. So first year is more or less common to all our programs. So with this exploring engineering, maybe we could give you some ideas and you can switch your program. In first year and beyond. So these, I mean, I mentioned already some skills, just bit of a reminder here. So these are the skills that you'll be developing in your first year and continuing into your program: resilience, creativity, collaborative work, etc., etc. Communication obviously is very important. You need to manage some projects that you'll be doing, working in groups or individually. You need to learn professional practice, which means that how you are going to deal with your work when you start your job, and obviously technical skills. So this is a typical week for mechanical engineering or engineering in general. You can see that it's fairly full. This is just to give you an idea. It's being an engineering student is a full-time job. Okay, so you have to allow for this. That will be coming every day. There will be some lectures, some labs, some problem-solving classes, or some call them like tutorials, academic tutorials. We tend to leave Wednesday afternoon free. That's why it is in gray there. For extracurricular activities, you may want to do some sport or be part of the student union. So usually it is always free. But I think it's good to mention that so that you know what to expect when you start an engineering degree anywhere. Right, so what you study in later years. So we looked at the modules that we offer here in our first year. In later years, these are not modules, these are just topics. Obviously, you will be continuing with mathematics in your second year. You'll be looking at energy conversion. There will be a little bit of robotics, environmental engineering, materials. Maybe in third year, we'll be touching upon combustion. You'll be looking at solids and failure of solids, heat transfer, fluid mechanics, thermodynamics, and gas turbine cycles. When I mentioned gas turbine cycles, for those maybe who are into that already, this is what powers aircraft, or aircraft and engines are based on gas turbines, but here we are talking about the power generation. But it's the same principle. And you'll be also doing some CFD, or computational fluid dynamics. Well, I'll give you an example in a moment. Okay, so let's just maybe give you a taste, just an example of what you'll be doing. These are just examples, obviously. They will be doing many different things. So that will be in your second year. You'll be looking at energy conversion systems. So when you convert energy from one form to another form. So here, obviously, you all recognize the picture of a wind turbine. This is offshore wind turbines. But did you know that this technology here of wind turbines is quite old? And you may have seen something similar to this windmill. Okay, it's exactly the same thing. So the technology has been around for centuries and centuries. We harness wind energy that comes into kinetic energy. So that's the speed of air or wind. And they do that energy makes those blades rotate. And then we end up with this rotational movement. And then we do whatever we want. Okay. On the right-hand side, we use just to get to that mechanical power to grind some wheat, for example, or coffee or whatever it is. Nowadays, we convert kinetic energy from the wind into mechanical energy first, and then that mechanical energy is converted into electricity. So there are two conversions in a row. Okay, the sort of things that you will learn, obviously how it works, the parts, etc., the science behind it, the equations behind it. But this is just to give you an idea that as future engineers, you need to look at things much deeper than just an equation. So for instance, here, what we're trying to show is the question, can we convert all energy or all power in wind? Remember, energy and power are linked. If you divide energy by time, you get power. Okay, so it's just a rate of change of energy. So you have that power in the wind. The question is, can we convert it all into electricity? Some of you will already answer, probably not, because you know there are efficiencies to take into account or inefficiencies, which is true. And those inefficiencies, or where we are losing the efficiency, when we say the inefficiency, it means that I cannot convert 100% of the available power or energy in the wind into electricity, it has to be less than 100% or less than 1. We know there will be some friction between the wind and the blades within the system itself, mechanical system. There is a shaft rotating, so there will be friction again in internal parts, so that will generate heat. So we will be losing, from one aspect to another aspect. However, what I wanted to share with you here is if you forget about the efficiency, okay, let's say we can convert, I don't know, 50%, and 50% will be lost due to friction, for example, and other things. Okay, let's forget about this efficiency thing. Can we still, if everything was perfect in ideal world, no losses, can we change all that power in the wind into the electrical power? So that's the question you need to you learn how to ask yourself. This is just an example, but you'll have to do it for every system you'll be looking at. And the answer here is no. And the reason is, if we are to convert every single joule or watt in terms of power from the wind into electricity, it means that air would have to come to a standstill, okay, after it goes after the blades. Why is that? Because you know that kinetic energy is half of mass times velocity squared, yeah? So to harvest 100% of the energy, it has to be half of the mass of air, or mass flow rate of air, times the initial velocity before the blades, minus half of the mass flow rate times the final velocity, which must be 0. And this is how you harvest 100% of it. But if you think about it, if your velocity after the blades is 0, it means that the air is not moving anymore, which means that the incoming air will hit like a wall. So it's absolutely impossible to convert 100% of the energy, regardless of the efficiencies. Okay, so this sort of things you need to know. And in fact, there's a scientist called Letts who came up with an equation which showed that you can maximum convert 60% of the power in the wind. 60%. Anything less, more than that, you will get that problem with the velocity too small after the blades. Okay, so in year 3, this is a picture of a fluid flowing around the cylinder. You can see the cylinder here. Okay, this is a cross section of the cylinder. This is a fluid. You can visualize it because there is some sort of smoke, and it is being sent from left to right. And you can see that there is a lot of turbulence. You can see that it starts very nicely, very parallel lines here. And then when it hits the obstacle, which is like a cylinder, you see how it becomes. It looks very complex. It's very difficult to write this into equation, to simulate this. People obviously tried in the past when people used to work by hand just with equations, but nowadays, luckily, I will explain to you how we do it. But if you want to do this by hand the old way, you need to solve these equations, and they are called Navier-Stokes equations. They deal with momentum, with the pressure, with temperature, with velocities, and you have to solve all these equations at the same time. And doing this by hand, I mean, you can, but it will take you a long time, so it's impossible. Obviously, nowadays, we don't expect you to solve it by hand, and there is software where these equations are being solved for you, okay? And you will learn how these equations are solved. They're not like this. They're not just put in a computer like this. They're what we call numerical methods, where you change these analytical equations into numerical systems. And this is what CFD I mentioned earlier is based on. So CFD, computational fluid dynamics, as we saw the example earlier, fluid flowing around the cylinder. We use software for CFD, for example, and you can solve your equations, and you can find the velocities, you can find pressure, temperature, whatever you need. Okay, so you will be doing this, and in the middle here you can see an example of some liquid flowing inside a pipe through a valve. And again, you can do the simulation through your software, and you can calculate whatever you need. The Third example here is a car where we are looking at the flow of air around the car. And we know that we need to make the flow as smooth as possible to reduce drag. Drag is resistance to air from an object, because the more drag you have, the more resistance, the more friction, the more you consume fuel, because you have to overcome that force of drag. Okay, so this is done in this example through simulation again, and you will notice that only half of the car is simulated. You can see, yeah. And this is something also we will learn to optimize your design as engineers, because everything is symmetrical, so there is no point of simulating the whole car. We just do half of it, because the other half will behave exactly the same way. And these tips and these little things you will learn. This is another example. Most of you will recognize the front of a jet engine. So this is the compressor, or the first stage compressor, which is also called the fan. This is on the outside, this is on the inside. This is the higher stage compressor, and you can see that the blades here have been damaged. So some sort of things, the engine has, or something hit the engine. It happens a lot with birds, and it damages the blades. And in fact, these accidents happen, and this is an example from a Australian airline aircraft, and it created a lot of damage in the engine. Luckily, nothing bad happened to the passengers. The aircraft could land safely with the other engines. It had four. But the point is, simulation and computer-aided engineering for solids and fluid is very important, because you can do your simulation and you can see, you can figure out how the damage occurred and how you can do to make sure that next time, if it happens again, the blades will resist that sort of damage. So these are just a couple of examples to tell you what we will be looking at in year 3. Just examples, many other things. Obviously, here in the examples I'm showing you, it's biased towards my own field, which is heat transfer and thermodynamics. But if you're interested in another aspect of mechanical engineering, obviously you will find it. Okay, so projects in third year, you'll be doing like a group project with the individual components. Again, this is a heat transfer example because of my own subject interest. I teach heat transfer and fluid flow. So this is an example our third year students work on. You can see it's a small heat exchanger that allows heat from a computer chip, for example, to dissipate to the outside. Otherwise, it gets too hot and can get damaged. So there's a simulation work here, okay, to find the best configuration, to make sure that it works, etc. This is another example of a project, third year project, where a group of students worked on cooling of an electric vehicle battery. We know that whenever electricity flows, it generates heat. When you have like a car that is powered by a battery, it takes a lot of energy in there, so it gets very hot, and you need to make sure that it's cooled down properly. Otherwise, it may catch fire. So it could be like a fire hazard. And also to make sure that the charge doesn't lose the charge very quickly. So this is a good example of projects where you work in groups and looking at different aspects of this problem. It involves chemistry, chemical engineering, fluid mechanics, heat transfer, electronics, etc. If you are interested in doing an MEng, I will talk about MEng in a moment, the difference between MEng and BEng. In your fourth year, you'll be doing another project, which is likely to be fully as a group project, where in third year, it's a group project with strong individual components. But this is a group project, and usually they are linked to industry. So most of the time, our industrial partners come to us and say, we want to solve this problem, I have this problem. And this is given to MEng students in their fourth year to look into the problem and find the solution. And you can see here examples. Okay. Another example of for group projects this time for MEng programs. And again, it is biased towards my field, which is heat transfer and thermodynamics. So this is an example of a condenser. A condenser is a heat exchanger where we move heat from a fluid to another fluid, from somewhere to somewhere else. I mean, your radiator at home is a heat exchanger because it moves heat from your central heating system, if you have a boiler, to your internal air inside your room or house. Okay, so it's different types of heat exchanger. So this is one here where fourth-year student looks into both in terms of simulation. You can see here the results through the simulation and also through experimental work as well. Okay, so for this to happen, obviously we need to have some facilities. These are examples, some of the labs that we have. We have general teaching labs where first year, second year students do their labs. We have the aerospace lab. We have like a wind tunnel. You may think, okay, they're talking about aerospace lab. How is it relevant to me if I want to do mechanical engineering? Well, aerospace lab has a wind tunnel and cars, certainly sports cars, are tested in wind tunnels as well as aircraft because we want to make sure that their aerodynamics are good enough to lower their resistance to air. We have fluids lab, computational mechanics, etc. And you can, I'll just leave you to read the different types of labs we have. And they're open to everyone. If for your project you need any of these labs, they're open to you. So it's not aerospace, only use aerospace lab, etc., etc., or bioengineering students will only use biomechanics lab. It's not true. It's open to everyone according to your needs. This is our makerspace and workshop. So here you see examples of students making things with their own hands, using tools, machine tools, or their own hands. So it could be working with wood, with metal. We also have like a 3D printer. So sometimes for your projects, you need to make some parts from scratch using any of these materials, and you can do that. And it's very, very good skill to learn. And we have these facilities. So this is just pictures of one of the labs. This is an area that we use for multiple things. We can use them for labs. You can use them for teaching, for seminars. It's a very nice room. So this is just an example there. A lot of money has been spent recently and continue to be spent. We keep so that a lot of refurbishment being done. This is a recent one, but a lot of things are currently being done as well. Okay, so how we support you in your studies? Before you start, you come to what we call a welcome week. So it's a week where there are no lectures. This is just before you start your teaching, your studies, where you get to learn how the university, how the faculty, how the school work. So you need to figure out, how to find your way, throughout the campus, how to use our virtual learning environment, VLE, which we call QM Plus, Primary Plus, where to find information, who's doing what, etc. So that's first week is just there for you to get used to the system. But during your studies, we have what we call problem-solving classes. I mentioned that earlier. These are academic tutorials where you go through problems, exercises and problems to cover the lectures. Some of modules have them, some others haven't. It depends on how you learn. Every single student will be allocated to an advisor, an academic advisor, and you can have individual or group meetings with your advisor once a week, so that you can ask any questions and you can ask for help. If they cannot help you, they will direct you to the right person, and you can talk about anything in those sessions. So these advisor sessions are not academic tutorials. It's not for you to do maths or physics or whatever. It's to talk about your own life as a student. You have what we call peer assisted study scheme, and we call it PASS. This is where higher level students in second, third, or fourth year, they are there to help you with your studies. So you can go and tell them, well, I'm I'm doing now this maths topic. I don't know, for example, simultaneous equations, or I don't know, or derivatives or integration, and I have difficulties understanding this specific point. Can you help me? And they will help you because they have done it. Okay, they have gone through the same learning experience. They have gone through the same modules. So these are we choose the students according to their attainment, and there's very serious, and just sit down with them. We allocate a room 1 or 2 hours per week. You can go there anytime, and they help you. And we have what we call teaching associates and teaching fellow, and they help and they support the lecturers for each module. You can also get help from them directly. So how we support you beyond your studies? So we have these career workshops, and they start quite early, where you learn how to write your CVs and cover letters, and how to do interviews, etc. And you may think, well, it's going to be too early. It's not going to be too early, because you can start looking for a placement, summer placement to start with, and you need to write a CV, you need to write a letter, etc. So you'll get this throughout your years, throughout the whole program, where you're going to learn more and more about this until you'll be ready once you graduate. We have an industrial placement manager. So for those who have like a year in industry, for example, we have a dedicated person to help them find a company or with the process, etc. And what I said earlier, we have great links and with excellent links with industry. We use them for the benefit of our students, and we have twice a year what we call ILF, Industrial Liaison Forum. This is where we invite people from industry, and we can talk to them, we can mix with them. We have like some seminars, etc., etc. And we have some industrial visits. We used to do that before COVID, where our students go to some sort of factory or industrial partner, and they go there. It has been stopped, obviously, because of COVID, and it might restart soon. Okay, so this is just an example of industries where our students can find work, and usually we work with them as well for research or even teaching. So you can see here some big names, Rolls-Royce, etc. TfL, Transport for London. I just let you see for yourself. These are just rough examples. Right, now, if you want to join, what we offer here for our mechanical engineering programs, we do the Bachelor's of Engineering, or BEng, and Masters of Engineering, MEng. The BEng is only in 3 years. That's the minimum, 3 years. You can add a year in industry, that becomes 4 years, or you can add a year abroad. Okay, so you can do BEng in 3 years, first, second, and third year, and you can have a fourth year, which usually happens after your second year. So you do your first 2 years, then you go to your industry placement as your third year, if you prefer, and then you come back to finish your last year. Or you can choose to go and do a study abroad. Okay, it's one of the other. You can combine both. If you do an MEng, obviously an MEng is 4 years. So you do your normal 3 years for like a BEng, and then you have an extra year. We have other modules, and this will be at a higher level, what we call level 7. And you can also combine with year industry, which becomes a 5 year in total, or a year abroad, which again becomes 5 year in total. What is good is you can change your mind. So you can start with an MEng, and at the end of your third year, you may think, okay, probably I will stop here. You can do that. You can graduate with a BEng, or vice versa. You can start with a BEng and then decide, oh, after all, I would like to continue to an MEng. You can do that at the end of your third year, provided that you have like minimum like 60%, I think, overall, and with some modules, you can switch to an MEng. So it's fairly flexible. We also offer a foundation year with our BEng. A foundation year is like for those who maybe don't have the subjects they need to do engineering, so they can start with what you call year zero, because it's before first year or foundation year. It's part of your degree. So this becomes part of your degree. So instead of doing a B Eng in 3 years, I'm not talking about like with industry or with study or just a typical 3 year B Eng. If you start from year zero, that will become a 4 year. But again, even if you start from a foundation year for any reason, you can still combine it with year in industry, and you can also move to an M Eng after your third year. Okay, so that's very flexible, a lot of possibilities there. In terms of entry requirements for 2024, we need 3 A levels, and obviously maths has to be one of them. AAB for a B Eng and AAA for an Eng. If you don't get those grades, depends on your offer, obviously, you can opt to go for foundation year. And I think it is a BBB requirement to start at the foundation year at the moment. Okay. So even if you get an offer and you don't make your grades, you can still join with the foundation year. Obviously, the international baccalaureate or IB is also accepted, or BTech with the triple B distinction. Okay, and you can look at the subjects there. Obviously, there will be more details online. You can look at these online if you need more information. I think that's the last slide. Yeah. So we have finished. I hope that you have learned something. I'm not sure, Michael, if you are here, I'm not sure if you can have questions.
Yeah, so basically, if anybody's got any questions, we've probably got about 2 or 3 minutes at the moment. You can put them in the Q&A. So you don't have the ability to turn your cameras on or anything like that, but there is a little Q&A box at the bottom of the screen. If you pop your questions in there, and then we will try and answer those for you. I'll just give you a couple of minutes to see if there's any. So one question, can we have a recording? So we're going to work on that. We're making a recording of today's session, and then ideally what we'll do is we'll email you out a page where you can go and review the recording again.
Okay, I can answer the next question. Can I do mechanical engineering without A-level physics? Well, you can have chemistry instead of physics, but you need to have one of the two. If you don't have any science modules, you can go through the foundation year. That's your options. Well, are there enough engineering jobs inside London? That's a good question. I know that there are many industries within the M25. I mean, a good example is not far from Queen Mary, from where we are, is the Ford Motor Company. They have a factory next to us, and many students find it good, to remain in that area. Yeah, but I know that there are many. Obviously, we cannot just mention them. Okay, if I continue IB maths. Okay, I mean, if you have like qualifications that not a bit unusual, I think it's better to talk with the admission team, and they will be able to tell you exactly what combinations are acceptable and what combination are not. So here I can see that you have like an IB and BTech, etc. Yeah, it is too specific to answer now, so I think it's better to get in touch with the admission team, and they will be able to answer that. Student accommodation, I think first year students have priority to get a room in our halls. Obviously, I cannot be 100% sure, but I'm not involved, but I know that most of students, if not all, get a room, yeah, in their first year. How much of the course involves practical application? Yeah, there's a lot of practical stuff. I mean, in your first year, if you remember, I mentioned 2 modules, and they have, it's all about practical work. which is experimental stuff. So two modules out of 8 are dedicated to practical work. But also there are other modules where you will do some practical stuff like engineering design. Yeah. The last question, or well, I'm saying the last that I can see anyway. It's about switching to another engineering degree after third year. No, you cannot do that. You cannot do a BEng in mechanical and then continue on to an MEng onto aerospace. No, you cannot do that because after first year things will change. You'll be doing different modules, but you can change after your first year, and that's it. What can we do aside from our studies to prepare for this course, especially mechanics modules, which I heard are very difficult? Um, well, I mean, this is difficult to answer because it depends on the students. It depends on what you are doing, what subjects you are taking. We tend to start from scratch for our first year modules. However, I fully understand that some of you may be tempted and would like to look into, do some work during the summer to be fully prepared. That's good if you are willing to do that. But I think physics and maths probably would be good things to do to look into if you want to do mechanical engineering. Do you take year 12 research students? I'm not sure I understand that question. Well, I mean, we take students with their A-level qualifications or equivalent qualifications. It doesn't matter if you have, I believe, it doesn't matter if you have reset your year 12. It's the qualification, I believe, that at the end it is your grades. Again, maybe this is something to ask the admission team. And do you help students to get a placement abroad for the year abroad? Yes, we have our, we do work with some universities abroad. I think I cannot tell you exactly which ones, but there's a small list of universities because you need to match their program, the modules will be taken there with what you do here so that it's not completely out of sync. But there is something you need to know is if you go abroad and do some modules there, it will not count towards your degree at Queen Mary. So it is like, so you won't be able to take exams and then it will count here. Okay, you just go for the experience, maybe a different language to learn from others in a different way, etc. So it's good for your experience, but the modules will not account for it towards your degree. Okay, personal statement. It is important. Obviously, you have to show that you are really interested in mechanical engineering and that you can do it well. It isn't. I mean, it is something to be taken seriously, but not to the extent that maybe you lose sleep over it. But yeah, I mean, focus on your grades. That's your most important things. With the best you can for your A levels, but also yeah, work on your statement. Okay, what's next? What extracurricular activities? There is none specifically. I mean, if you do some, that's great, but we don't specifically suggest that you do this or that. It's up to you, really. I mean, some students want to do sports, they can do that because it makes maybe their minds fresh, for studying. But however, having said that, I mean, you have some clubs that you can change or societies that you can join or societies that you can join. For example, we have what's called Formula Student. For those of you who know about Formula One, this is a little bit similar, but called Formula Student. where a lot of universities build their own car. Yes, you heard me correctly. We have a team and they build their own car and they take it to race against other teams from other universities. So this is a good extracurricular activities that you can do. There are other things as well. Do you have small study groups with tutors? I take it as you are talking about academic tutorials. It depends on the modules. So some modules have bigger groups and some others have smaller groups. What we call tutors are probably demonstrators helping you with solving problems. Yeah. Well, there's another question about personal statement. Unfortunately, I won't be able to elaborate on personal statement. So again, this is probably something that you should ask the admission team. I mean, all I can say is make it as good as possible. Don't overstate things and don't lie. Just say the truth. Just say what you feel, why you want to do it. There is not a good and bad answer for a statement. It's really who you are that should come across. And how many students will be in the lectures? First year, for the whole school, so that's all programs together, this year is about 430 students, okay? However, mechanical engineering is obviously part of that group, aerospace is part of that group, etc., etc., okay? So you'll end up in smaller groups in some modules. Yeah, it depends on the modules, how many students will be in lectures. It depends on the modules. So some modules you'll have like okay, let's go back to that modules about experimental work.